Good afternoon, judges. We are Team 51 Lobang Infinity, and this is our presentation for knowledge and collaboration, problem statement 1. Traditional education systems adopt one-size-fits-all approaches, leaving students who learn differently behind. Now, regular models are rigid and fixed in the syllabus and curriculum and in their modality of learning. We believe that there is a need for dynamic and responsive systems that adapt to the students' needs. Our solution is Eduverse, and the key tagline is that since no two students are alike, we believe that with Eduverse, no two lessons will be. Now, what it does is it dynamically adjusts the lesson difficulty using an AI model known as deep knowledge tracing. It personalizes content type in three modes: visual, auditory, and kinesthetic, and continuously assesses progress and ensures the privacy of students. For our tech stack, we used Next.js, a React framework, and Supabase as a relational database and authentication provider, Cloudflare for protection, and PyTorch to train our DKT, deep knowledge tracing models. The model was trained on the Assist 2019 student learning dataset, and this model was exposed via Fast API as an endpoint that Next.js could utilize. Now, the AI model that we used is known as deep knowledge tracing, and a dive into this model is essentially it takes in features from interactions of the students with the first n questions. Now, after the student has interacted with these questions and fed the model these key features that I'll go through in a while, the model predicts the aspects of the next interaction n plus 1, the n plus 1th question. Now, the key parameters fed to it were the question ID, the correctness of the student, means whether they got it correct or wrong, the confidence that they indicated on a scale from 0, 1 to low, medium, high, and the difficulty of the question also in the form of low, medium, high. Now, this model is a LSTM recurrent neural network, and at the end of the day, it predicts the probability of getting the next question correct based on the question's difficulty and exposes this to an endpoint that our front end uses. Now, based on pedagogical research, it has been shown that visual, auditory, and kinesthetic learning go hand in hand and exhibit a much higher rate of retention than any of the modes alone. However, we believe it is essential for students to first have a strong fundamental in understanding visual content, and if they are unable to understand it, then revert to video lectures, and lastly revert to interactive animations or kinesthetic modes. So essentially, when this model prediction drops below a threshold, we simply switch the modes. So once they get questions wrong or have a low confidence rating, it first shows them a revision using PDF notes, after which if it drops below the next threshold, it recaps using a video lecture, and lastly it revises using interactive animations. And if it finally drops below the threshold again, means that the student has not grasped the concept after going through all of these modes of learning. It implies the student has fundamental conceptual misunderstandings, in which case we need to revert to the previous linked topic, which the teacher will indicate how the topics are linked and related to one another. So for our demonstration, we have authentication, and I'm going to showcase the teacher's portal first. So once the teacher logs into the portal using their email account and their password, it leads them to a protected endpoint to prevent cross-site reference forgery, and they are able to create a new class. So for example, in this case, the new class is created and it generates a 6-digit unique ID that students can use in order to join the class. So first, what the teachers can do is create a lesson flow. A lesson flow is simply a set of topics arranged in a lesson plan. And in this case, the multiple topics can be assigned per week. And finally, once all of these topics have been assigned, what happens is that these topics show up on a interactive flowchart over here, in which the teacher can create linkages between the topics. These linkages are important because it shows our back end what the previous topic was, or what topic the question generator needs to fall back upon if the student has fundamental misconceptions. After this is created, we save the timeline and return to the dashboard. Now, following this, teachers can also upload notes. Let's use recursion as an example. So recursion was linked to the topic of functions. So first the teacher uploads PDF notes, followed by a YouTube video URL, and lastly the teacher can also upload an animated embedded link. So this animated embedded link is shown as an iframe and can either be contributed by the teacher, the institution, or the community, the wider community. After this, what happens is the materials are saved and can be accessed. So once a student logs in, they can join a class using the class code and the passkey, after which they will be able to access the lesson notes, namely the PDF notes, the video lecture, and the animation. After this, the teacher can also create an assignment. An assignment is basically a collection of questions on a certain topic. So for example, this assignment is entitled recursion revision and can be filtered, and the question bank can be filtered based on the module, the topics, and grade levels, and several other features. So in case this question bank proves insufficient, the teacher can also create their own custom question. Creating a custom question basically involves keying in some key parameters and labeling the multiple choice question options. After the due date is set, the teacher can then select the assignment topic and assign to the students. After this, students can then go and complete the assignment. Now, if let's say this is basically done in order to get the model to predict as low a score as possible, so that once the students gets it wrong, immediately it reverts to one of the modes. So over here now it should revert to the video mode, and lastly it will revert to the mode of animations, the kinesthetic modality. Now, if that falls below a certain score, now it has reverted to functions, which is the previous topic in this chapter. Now, if the topic on functions has been completed well, it can now bring the student back to recursion and allow them to complete the topic as they would have normally, now with strengthened fundamentals. In essence, the main concerns now are ensuring the data privacy, and this data is all anonymized, and only admin roles or teachers can access this data, and row level security is also enabled in order to ensure that students can only see their own progress and the teacher can only see students in their own classes. Now, for the future of Ediverse, what can be done is the implementation of gamification, which helps to keep the student engaged in the topic. And the use of streaks, badges, achievements, and leaderboards are also well studied techniques that improve student engagement. However, the main focus of our project today was to showcase the switching between modalities and adaptive adjustment of lesson difficulties. And with that,